So today we're going to be looking at maximum and minimum coordinates, right? So for maximum coordinates, I'm explaining the handout now, right, for you all. So sometimes we are asked to express a quadratic function of the form ax squared plus bx plus c. So that is how a general quadratic function is written. And we are asked to express it in the form a into x plus h squared plus k, or sometimes the h and the k are replaced by b and c. So sometimes we could be asked to express it in the form a into x plus b squared plus c. And I want you all to note that when they ask you for the y value is the same as the k value, right? So that's supposed to be y is equal to k or y is equal to c, right? So you will just take a note of that. Y is equal to k or y is equal to c, right? Same thing here. Y is equal to k or y is equal to c. Everybody follow? This is I remember I typed up this like 5 minutes ago. So with maximum coordinates now, sometimes we are asked to express a quadratic function of the form negative ax squared plus bx plus c in the form k minus a into x plus h all squared, or sometimes we could be asked to express in the form c minus a into x plus b all squared. And it's supposed to be y is equal to k or y is equal to c, right? Now it is important that when writing our values in the form that we are asked to write it for maximum coordinates, we only take the a value and we're not taking the sign. This applies only for maximum coordinates. Now I know what I said just now will not make any sense to you as yet until we actually start to practice with the questions. Only then and there it will make sense for you, right? Now I'm talking about getting k and h and stuff like that. How on earth you might be wondering how on earth we get an h and k? Well, you have to use these two formulas here. They are not in your formula sheet, so you have to memorize them. So h is equal to b all over 2a, and k is equal to 4ac minus b squared all over 4a, right? And of course, if you're expressing it in this form, the value of a will be this a value here. And of course, x is just x plus h, and I showed you how to find h. And of course, squared plus k, and I showed you how to find k, right? Of course, if they give you to find it in this form, then you would not put h, you would put b. And of course, you would not put k, you would put c in terms of the formula here. Any questions so far?
No, sir.
Okay, great. So this formula is used for both maximum and minimum. So let us take a look at the past papers. So just give me a moment. Let me just pull it up here. I sent it for you all on WhatsApp, so you're all supposed to have it. Topics, minimum and maximum. Right. You all see me 2011 here?
Yes.
Right. So May 2011, number 9, is telling us that the function f of x just means y, is equal to 4x squared minus 8x minus 2, and we are asked to express it in the form a into x plus h squared plus k. Of course, where a, h, and k are constants. We're getting 2 marks for that. And also, we are asked to state the minimum value of f of x. And also, we are asked to state the value of x for which f of x is a minimum. So everybody following with our question there, right? Everybody okay?
Yes. Yes, sir.
Right. So let's see how we will actually solve this question using the formula that I gave you. Hey, Bala, welcome. So we are asked to express 4x squared minus 8x minus 2 in the form a into x plus h squared plus k. All right, so let's identify our values first. The value of a is, remember this is in the form ax squared plus bx plus c. So the value of a is really 4. The value of b is -8. And the value of c is -2. So let us just quickly state our form. Just give me a minute. Right, sorry. We are asked to express it in this form, right? And remember I told you how to find h. H is b all over 2a. So h is equal to b, which is -8, all over 2, and the value of a is 4. So h is -8, all over 2 by 4 is 8. 8 into 8, 1, 8 into 8, 1, and of course the negative sign did not cancel, so our answer is -1. Now we are asked to find k. Not asked, we are required to find k. So k is equal, anybody could tell me? How do we find k? 4ac minus b squared all over 4a. Thank you so much for all your help. That is so helpful. K is equal to 4, and the value of a is 4. The value of c is -2 minus b, which is -8, all squared, all over 4, and the value of a is 4. So let's use our calculator. So 4 open brackets, 4 close brackets, and next bracket, -2 close brackets is equal to -32 minus, and of course, -8 squared is 64. All over 4 by 4 is 16. So -32 minus 64 is -96. And -96 over 16, our value for k is -6. So now we are asked to express it in this form. So the value of a we know is 4. So we write 4 into x plus h, and we just work out h to be -1. So a positive and a negative gives us a negative, so we could change this to a negative 1 time, squared, and of course plus k, and k is -6. A positive and a negative is a negative, so we could change this to -1 time. Right? So this is how we form a into x plus k squared plus h plus k. Anybody has any questions? Anybody?
No, sir.
All right. So I'm giving you all a minute to take it down. We have a next part of this question to do, right? This comes for 2 marks. We'll just do one more of this, and then I'll do a maximum question for you all, and then we're moving on, right? If you all have any questions, stop me and let me know, right? Okay, so I'm taking it off now, right? So the next part of the question, it says to state the minimum value of f of x. So the minimum value of f of x. Okay, and remember I told you that f of x, when we did functions, is the same as y. So they are asking us for the y value, and remember I told you just now that y is equal to k. Remember I told you all that? And k was equal to -6 just now. So that means, well, therefore y is equal to -6. Any questions there?
No, sir.
Okay. And of course, can you all recall the question, the answer just now? Sorry. The answer is, what was the answer? It was 4 into x minus 1 squared minus 6, right? This is the y value here. This is the key. So this here, what is inside of the bracket is what we take in to help us find the x value. So we take out whatever we have inside of here, x minus 1, and we put it equal to 0, and we solve for x. So we take this, fling it across, x is equal to +1. So this is the second part for 1 mark. Anybody have any questions?
Nope.
Okay. So let's try our next pass with a question then. Let's try one from 2013. Again, I send this to you all, right? So shucks, just now. Right, you all seeing it? I only want you all to do part 1 and part 2 because part 3, although it is part of the question, it's a different topic, and I teach you all that topic already. Let's just quickly review what this part 3, what part 3 is asking us. As you all can see, it's a quadratic equation, and it's asking us to write our answer correct to 2 decimal places. Now remember, I showed you all several ways to solve a quadratic equation. You can solve it by factorizing it, by the graphical method, by the quadratic formula. And which of those 3 that I taught you all so far usually gives us our answers in decimals? Anybody can tell me? Johnson, you want to tell me?
Quadratic formula.
Correct. The quadratic formula gives us our answers usually in decimals. So we will use in this one here, we would have used the quadratic formula to solve the 2 values for x, right? And that would have been for 4 marks. So that's a different topic, and we're not going to waste time doing that because we did quadratic formula already. Okay. So just focusing on part 1 and part 2. I'm giving you 5 minutes to try that, and then I'm going to correct. Okay, can we correct? Yes. Okay. So here we are asked. I lost the question now. But which one is it? 2013? Yeah.
Jan 2013.
Right. Thank you. Right. So we are asked, okay, where is my marker now? Oh. So we are asked to express 3x squared minus 5x plus 1 in the form a into x minus a. Oh, this is the question with that. It's supposed to be plus, right? Plus k. So a is equal to 3, b is equal to -5, and c is equal to 1. So let's find h. H is b all over 2a. So h is equal to b, which is -5, all over 2 into a, which is 3. So h is equal to -5 over 6, right? And let's find k now. K is equal to 4ac minus b squared all over. Everybody want to help me here? You'll have it in your notes.
4A.
4a. So k is equal to 4 into a, which is 3, c, which is 1, minus b, which is -5, squared, all over 4 into a, which is 3. So k is equal to 4 by 3 is 12, by 1 is 12, minus 5 squared is 25, all over 4 by 3 is 12. 12 take away 25 is how much? -13 over 12. Or if you wanna write it as a fraction, is what? -1, sorry, and 1 over 12. Okay, so in the form a into x plus h plus k squared is equal, well, a is 3, x plus h, well, a minus and a plus will give us a minus, so 5 over 6. A plus by a minus is a minus, so you could use any one, -13 over 12, or you could have used -1 and 1/12. You all got that?
Yes, sir.
Okay. And the other part of the question, what was it asking us? The minimum value of f of x. So the minimum value is always the minimum value of f of x and the value of x. Okay, so basically they're asking us for the values for the coordinates. The minimum coordinate, right? So here they're asking us for both the x value as well as the y value. Okay, so can I erase this? I'll just erase it up here and do it on the top there, right? So remember, the y value, y is equal to k, and k is equal to -13 over 12. Therefore, y is equal to -13 over 12. And remember, I told you how to find for x, we're using this here. So let's find for x now. It's x minus 5 over 6 is equal to 0. So we take this, -5 over 6, and we carry that across. X is equal to +5 over 6. So the values of x, the coordinate will be 5 over 6 and y is negative 13 over 12. That's only the access to find it and to find the coordinates, right? Because remember, coordinates have the form x, y. When we did coordinate geometry, you're supposed to remember that, right? Okay. So y is this and x is this. Any question there?
No, sir.
Okay. So let us look at maximum coordinates now. So that was it for minimum coordinates. So please pull up your notes on maximum coordinates. I'm going to give you all a question to do for me. Now that you all are familiar with this topic, I will give you all a maximum question to do now. Just a minute. Right. So express negative 2x squared plus 4x minus 7 in the form c minus a into x plus b squared, where no, that's all.
Was that supposed to be minus 7 or plus 7? Exactly, that Wednesday was.
Oh, sorry, plus 7. My apologies. Thank you.
Welcome.
David, I now see a message that you're waiting for it. Just give him a little time, and if you don't get it by probably Wednesday next week, you could probably message him and ask him if he is sending it or if he sent it already and forgot you by chance or something of the sort, right? Yeah, I see you say still waiting on it. I'm guessing you're talking about the thing from this morning. Oh, okay. My apologies then. Oh, sorry. I now see you say still writing it. Oh, that's why I see you still waiting on it. My apologies. Okay, can we correct? So we have to identify what is A. The value of A is -2. The value of B is 4. And the value of C is 7. So we have to express it in the form, well, sorry, we have to find H, which is which is B, all over 2A. So B is 4, 2A is 2 into -2. So H is 4 over -4. K is equal to what? How we find K? So K is 4 and the value of A is -2. The value of C is 7 and minus B, minus B, which is 7 squared, right? All over 4 and the value of A is -2. So 4 by 2 is 8, and 8 by 7 is 56, and of course this negative sign makes it -56. And of course minus, and 7s are 49. So 56 take away 49, sorry, -56 take away 49 will give us 105. So K is equal to -105 all over -8. Negatives will cancel. So K would be 105 divided by -8, which is, okay, is this correct? Something wrong, hold on. 4E is -2, C is 7, minus B, oh, B is not 7. Thanks for helping me, people. And the square root of 4, sorry, the square of 4 is 16. So this will be incorrect here. So -56 take away 16 is -72. And -72 divided by -8 will give us +9. Everybody good?
Yes, sir.
Okay, so we have to get it in this form now. C minus A into X plus B squared. So what is the value of C? Oh gosh, it's not supposed to be K, eh? It's supposed to be C. My apologies. And this is not supposed to be H. This is supposed to be B. I apologize about that. Everybody good, right? Nobody confused, right? What I just did?
No, sir.
Okay. So C is 9, so we write a 9 minus A. And remember, I told you all in the note, we're just taking the value of the A, which is 2, and we're not taking the sign. Because if we are taking the sign, this would have changed this here. Okay? So it's just the value we take, not the sign. So just 2, X, and B. What is B?
4.
Wait, sorry. Yeah, no, B is -1.
Number 4.
I
What?
forgot to look at that. What's going on with me? I have no idea what's going on with me. So yeah, a positive and a negative because it's plus -1, and a positive and a negative gives us a negative. So squared, and that's our answer. Sorry for having made so many errors in this question. I apologize for that. Everybody good?
Yep.
Any questions there? Oh, David, I now seeing.
No, I don't have any.
And I'll see you was telling about the error I made here. So thank you for that. Okay, so let us start with our new topic then. Can I erase this?
Yeah, yes, sir, you can erase it.
Okay, great. So let me just get this note pulled up. Transformation geometry. Okay, so I'm erasing this, right? I'm going to write on the whiteboard, so you all will need to take down some notes, okay? Let me see if I can adjust this tripod so it's not shaking so much. Okay, hopefully that will help. Okay, so our topic is matrix transformations. Okay. You all can recall the movie Transformation? I mean Transformers?
Yes, sir.
Yeah, well, this
Yeah,
topic
I
is
watched Transformation.
very good. Well, yes, Transformers. That movie will not help you in any way with respect to this topic, right? That movie has nothing to do with this topic. Just making it clear.
Unfortunate.
So then why are you telling us about it, sir?
I was just trying to be irrelevant, right? Okay.
Okay, alright.
So let's look at the first one. I'm summarizing the handout for you all, right? So let's look at the reflection on the x-axis. The matrix for that is 1, 0, 0, -1. Okay? Secondly, reflection on the y-axis is -1, 0, 0, 1. Reflection on the line y = x is 0, 1, 1, 0. You already handout on matrices that I have. No, I didn't send that to you all. Not to worry, you didn't miss out on nothing. Fourth. Reflection on the line y is equal to -x. Tell me when I can erase it, right? I'm giving you all 2 minutes to write it down. I have to give you all a few more. Just 4 more again, and that's it. And these you all have to memorize them, yeah? You have to commit it to memory. Yes, transformation, Transformers. I keep using transformations. Transformers was a real good movie, Johnson. I enjoy that.
My favorite one was Transformers 4.
I can't remember which one is 1, 2, 3, 4, but all of them was good. Brain food. By the way, I was supposed to tell you all, I don't know how come I didn't tell you all that, but as students, it is very important to nourish your bodies and to be taking vitamins as well, right? Now, you all can have your parents buy you some very, very good brain vitamins, right? But of course, go to your pharmacist, go to the doctor, etc., and ask them if to recommend a good one for you. I'm not a doctor, I'm not a pharmacist, I'm just making that disclaimer. So I could just tell you what I used to use when I was a student, and it worked really well for me and my sister. And it's only when we started to use the tablet, then we started to actually do well because we were able to function in class and focus, and whatever we were studying, we were actually able to retain it. And the name of the tablet that we used to use was Mentat, Mentat. And it's just like about $60 for a bottle with 50 tablets in it. And you take one in the morning and one in the evening. Well, I think two in the morning and two in the evening. I can't remember. The bottle had the directions, but we only used it when we were going to school. I stopped it when I finished my degree ending. And I used it up until I was an adult. And it worked really well. So you can probably check it out. I know there is another one, I think is BioStrat. That's the next good one I know too. But the one I used was Mentat. Of course, it smells horrible, but it's worth it. So
Tinas were good enough.
was that?
Well, Tinas were good. The mental performance.
But yeah, you all should invest in some have your parents buy you all some vitamins and stuff. Because I see some of when we used to have the classes, I used to see some of them falling asleep and thing, and I was supposed to tell you all about investing in some brain tablets and thing, and vitamins and stuff. Anyway, let's continue. Y'all, I talk enough. You all had enough time to write on this. I'm taking it off. You have 4 more to get. Right, so I'm going to show you all how we're going to use these matrices just now, right? These matrix questions. Can I erase now? Or are you all still writing? Is this still breaking up, David?
You can erase, sir.
Okay, no problem. Everybody else was here, and am I breaking up? Okay, I'm erasing, right? So you all have to pay attention to the questions and see what they are asking you for. Let's take a look at one of the questions then. So here we are seeing that the triangle PQR has coordinates for P as 3, 5, for Q as 6, 5, and R as 6, 7. We are asked to determine the coordinates of the origin, determine the coordinates of the image of triangle PQR under a reflection in the y-axis. Okay, so everybody have an idea of the question, right? Let me just write on the points and just take a jotting of the points, people. So P is 3, 5, Q is 6, 5, and R is 6, 7, and it's the y-axis we're using, right? So I'm switching to the whiteboard now. Right. So can you all recall the matrix reflection in the y-axis? Anybody? That's the second one. So that matrix that we are using will be what? -1, 0.
-1, 0, 0, 1.
Correct. So let's find our new points now. So let's start off with P. It's 3, 5. We write it in column matrix format. And of course, -1, 0, 0, 1. So it's first row by first column, and then first row by second column, second row, first column, second row, second column, right? So let's do it. 3 by -1 plus 3 by 0. My marker is dying. Then 3 by 0 and 3 by 1 plus 3 by 1. Then 5 by negative 1 plus 5 by 0, and then 5 by 0 plus 5 by 1. 3 by negative 1 give us negative 3 plus 3 by 0 is 0. 3 by 0 is 0, and 3 by 1 is 3. 5 by negative 1 is negative 5 plus 0, because 5 by 0 is 0. 5 by 0 is 0 plus 5 by 1 is 5. So this will give us negative 3. Hold on, I think I do craziness. Everybody can tell me where I went wrong there? 3. Five. Yeah, I did this entire thing wrong. My apologies.
Not following your own rules. 3 by negative 1, 5 by 0.
What's that?
It wasn't following the rules row by column.
Yeah. Let me try it back one more time. 3, sorry, it's the matrix here. Negative 1, 0, 0, 1 by 3, 5. Right? So first row by column. So negative 1 by 3 plus 0 by 5. Then 0 by 3 plus 1, well, 0 by 3 plus 1 by 5. So this will give us negative 3 plus 0, and then 0 plus 5. So this will work out to be negative 3 and 5. Everybody good?
Yes, sir.
So P, which is 3, 5, is mapped onto, we call this P inverse, here P inverse, P1, which is negative 3 and 5. Can I leave you all to do the other two? I'm giving you all 2 minutes just to try the other two. Well,
So I'll do it, but can you explain the P part again, like the row and column thing that you were talking about, like how it goes?
this?
No, above that.
Yeah,
Yeah, like that area.
this part here?
Yeah, that part exactly.
Okay, so you were in the class when we did matrices?
Yeah.
We did that in our Sunday class. Right, so it's the first row by the first column, and then the first row by the second column, but it has no second column here. So it's just the first row by the first column. So it's negative 1 by 3, which is what I have here, plus
Okay.
0 by 5, which is what I have here. Then it's second row by first column, so it's 0 by 3, which is what I have here, plus 1 by 5. It's an algorithm.
All right.
And then negative 3 by 1, sorry, negative 1 by 3 will give us negative 3, and 0 by 5 is 0. 0 by 3 is 0, and 1 by 5 is 5. So 3 plus 0 is negative, negative 3 plus 0 is negative 3, and 0 plus 5 is just 5. So so P underwent a transformation, a matrix transformation, and the new value for it is negative 3 and 5.
Okay, thanks.
No problem. So let me do the other one quickly for you all then. Q will undergo the same transformation. So Q it's negative 1, 0, 0, 1, and of course 6, 5. So it's negative 1. I don't want to see a shortcut. How to do this? I don't want to see a shortcut, but it only applies when you're doing matrix transformation, right? I don't want to see a shortcut.
Yes, sir.
You just multiply negative 1 by 6, you get negative 6, and positive 1 by 5, you get positive 5, and that's the answer right there. So I showed you the long way, and there's the short way, right? So let's quickly find R. It's negative 1, 0, 0, 1. Oh, wait, let me just show you all this. Q, which was 6, 5, underwent transformation, and it became Q1, which is negative 6 and 5. Okay, so you can write it like this if you had to do a written exam. So R is, to find R, it's negative 1, 0, 0, 1, multiplied by 6, 7. So can you all guess what the answer will be? Negative 6, positive 7. Yeah? Negative 1 by 6 is negative 6. Positive 1 by 7 is positive 7. So R, which is 6, 7, underwent some transformation, and we got R1, which is negative 6 and 7. Any questions there? People?
No, sir.
Okay. So let's do the next question then. Of course, the working is here, right? Look at here in the thing. The triangle ABC has coordinates A, which is 2, 4, B, which is 7, 4, and C, which is 8, 7. Determine the coordinates of the image of the triangle. Determine the coordinates of the image of triangle ABC under a rotation about the origin through 180 degrees. You all know how to do that? So I want you all to take a note of what is A. A is 2, 4. B is 7, 4. C is 2, 7. And it's a rotation through 180. So that was the 7th one. So the matrix that we will be using is negative 1, 0, 0, negative 1. So I'm turning on the whiteboard now. All right, this is the matrix that we're using. So let's look at E. Negative 1, 0, 0, negative 1. And then we have A as 2, 4. So negative 1 by 2 is negative 2. Negative 1 by 4 is negative 4. So the values for A is negative 2, negative 4. So A, which is 2, 4, underwent a transformation and it became A1, which is negative 2, negative 4. Right? So you could say is mapped onto this. Let's look at B. B is negative 1, 0, 0, negative 1, multiplied by what B actually is, which is 7 and 4. So this will change this to negative 7, negative 4. So again, B, which is 7, 4, is mapped, or it underwent a transformation and is now mapped onto B1, which is negative 7, negative 4. And then we have C, negative 1, 0, 0, negative 1, 2, 7, negative 1 by 2 is negative 2, and of course negative 1 by 7 is negative 7. So C, which is 2, 7, when there went a transformation and it's now mapped onto C1, which is -2, -7. Okay? Any questions, people?
No, sir.
Okay, now I just saying in your exam, if it was a paper 2, you would have had to, they would have given you the coordinates, they would have they would have actually given you a diagram. And what some people just do is they just look at the diagram and try to count how many blocks it have away from one point and away from the axis and whatever. And sometimes they get the questions correct and sometimes they get it wrong. But to be more accurate, if they tell you that it underwent a transformation about the x-axis or whatever, depending on the question, you will know which matrix to use, right? And that will give you a more accurate, in fact, it will give you an accurate answer with respect to the coordinate that the old value would have been mapped onto. The old, so A is 2, 4. When the transformation, the new value of A is A1, which is -2, -4. And this will actually tell you where the new points will be. These here. Okay? So that's how this is helping you. If we had paper 2, if we had any paper 2 exam to write, I would have showed you all more of that, but I'm just going to focus more on the multiple choice for now. But everybody good, right?
Yes, sir.
Yes, sir.
Okay. Let's try another question. I'm going to give you all this one to do for me. One moment. Try the question. I'll be calling on people to answer for me. So this is the last question, right, for this particular topic, and then we're moving on to transformations. Sorry, geometric transformations. You all finished? That is correct then. So we have these, they give us this, and obviously they tell us here that determine the coordinates of the image of triangle LMN under an enlargement with center OO with scale factor 3. So we automatically know we're using this, right? And of course, K is the scale factor, and the scale factor in this case they tell us is 3. So for L, it's 3003, then 1, 4. So 3 by 1 is 3, and 4 by 3 is, well, 3 by 4 is 12. So L, which is 1, 4, is mapped onto L1, which is now 3, 12. M is 3003, mapped, sorry, then 3, 4. 3 3s are 9, and 4 3s are 12. So M, which was 3, 4, is now mapped onto M1, which is now 9, 12. And of course, the last one, we have N, which is 3003 and 1, 6. 3 by 1 will give us 3, and 3 by 6 is 18. So N, which is 1, 6, underwent transformation and is now N1, which is 3, 18. Do you have any questions so far? Oh, need to announce the answer there. Yeah, it's correct. So that's the end of matrix transformations there. Okay, so it's now 2:30. I'm giving you all a 10-minute break. We start back at 2:40, right? We starting back with transformation geometry. So I'm right here if you all need me. But we starting back at 2:40. Okay, can we start? Can we restart?
Yes, sir.
Okay, so we are going to be looking at transformation geometry. So I'm going to summarize the handout for you all, right? Just as I did with this one here. So I'm taking this off. Okay, so the first thing we're going to be looking at, well, the general topic is transformations, right? So what is transformation? So a geometric transformation involves the movement of an object from point A to point B, basically. And of course, this is more or less done on the Cartesian plane, which is the X and Y axis thing we did when we did the graphs, right? So the movement is more or less accompanied by a change in either the position, the orientation, that's whether is like this or like this, etc. The shape, whether it's triangle, etc. And the size as well, whether it's an enlargement or a reduction. Okay? Any questions so far? So the first one we're going to be looking at, yeah, I was wondering who's pundit? So right, the first one we're going to be looking at is translation. Now, when I say translation, I don't mean from English to Spanish or anything like that, right? Translation in mathematics is a movement along a straight line, and it has to be in a fixed direction without turning. So let me just pull up this in the handout for you all so that you all won't be too lost with what I'm talking about, right? Right, we here. Translation. A translation is a movement along a straight line in a fixed direction without any turning, right? So as you can see here, when an object undergoes a translation, all points on the object move the same distance and the same direction. And of course, the arrow will show us here. So this is the object here. It undergoes a translation, right? The translation is the same distance apart, as you can see, and of course, it moves in a straight line. How do you describe a translation? First, you describe the translation by defining. The translation is defined by stating, number one, the direction of the movement, right? Whether it's horizontal, vertical, etc., and the distance moved by the object. Okay, don't worry, I'll get this handout after, right? Let's look at translation in the Cartesian plane. I'm going to show you all an easy way to do it, right? So let us consider this here. Let's go straight to the important stuff. A positive value of x denotes the movement is horizontal and to the right, while a negative value of x denotes the movement is horizontal and to the left. So in this case here, remember this is in the form x and y, right? P is 3 and 1, negative 1, and the value of x here is 3. So it's a positive value, and the positive value denotes the movement is horizontal and to the right. However, a positive value of y denotes the movement is vertical and upwards, while a negative value of y denotes the movement is vertical and downward. You see this point here, this is the most important thing you need to understand here. So in this case, y is -1. So this will mean it's a vertical or downwards movement. Okay, everybody? Everybody good?
Yes, sir.
Okay, great. So let us look at this example. P is equal to 3 and -1. And they are telling us P is mapped onto P1 under the translation T, which is -2 and 3. Determine the coordinates of P1 under, P1 the image of P under T. Let's see how we're doing this. I will not use the whiteboard for this. I will use Microsoft Paint, right? Because I want you all to see the question while I'm doing it. So I'm changing to that now. Right. So to solve a question like this, it will be the object plus the transformation, which is T, which is equal to the image, which is, in this case, P1. Everybody okay? Again, P is the object, and to solve a question like this, it's the object plus the translation, which will give us P1. Okay? So what is P? P is 3, -1, plus the vector here, the translation vector is this. So plus -2, -3 is equal to, so 3 plus -2, a plus and a minus gives us a minus. So 3 take away 2 is 1, and -1 plus -3, a plus and a minus is a minus. So -1 minus 3 is -4.
Sir,
Uh-huh.
I have one question. Why you adding P plus T equal P1? I don't understand that part.
Okay, no problem. So let me just quickly redo it. The rule for this, to simplify, to solve this, if you don't want to do it graphically, you could do this graphically, yeah? But if you want to just get the coordinates, it's the object plus the translation vector. Well, plus the translation, let's just put translation, which will give us the image. All right, and our object is P plus our translation T is equal to our image P1. So P here, oh gosh, just now. Right, so this P here, this P1 here is our image, and T here is the translation vector. Sorry, I keep saying translation vector, is the translation here. Okay, so P is 3, -1, plus T, which is -2, -3, is equal to 3 plus -2 is +1, and -1 plus -3, a plus and a minus here is a minus. So -1 minus 3 is -4. Okay? So therefore, P1 is 1 and -4. Any questions there?
So when P equal 3 minus 1 is mapped onto P on that translation T equal -2 -3. So you have to add it.
Yeah.
Oh, thanks.
Yeah, no problem. Because they're telling us that P is mapped onto P1. So that means P underwent a translation, which is T, and it is now mapped onto P1. So let's try, let me give you all 2 questions to do one time. Just a minute. Right, here's your first question. And here is your second question. I'm giving you all 5 minutes to try them. Okay, anybody have any answers for me? Anybody? Okay, let's look at the first question then. So A, which is 3, 2, undergoes a transition, so plus T, and it is mapped onto A1. So we have A1 here. If A1, the image of A has the coordinates 7, 3, describe the translation T using a column vector. Oh, so you'll see here now that we have to find A. You all notice that? Yes, people?
It's not T we had to find?
Oh yes, I meant to say that. My bad. So yes, so A, which is 3, 2, something was added to it here to give us 7, and 3. Ooh, I wonder what those numbers could be. 3 plus what could give us 7? Anybody?
4.
Yeah. Oh, let's figure that out all on your own. My gosh, I don't need a teacher then. And 2 plus what will give us 3? Anybody get answer that? Give us $5 million.
I have no idea. This is too hard to figure out. It's like way above my.
One.
Intellectual capacity. It's way above your intellectual
The
capacity.
answer is 1. 1.
Yes, the answer is 1.
I want it in cash.
So T transition is 4, 1. All right, people? And let's look at the other one. So we have P. Let's do them in turn. So we have to find P, we have to find Q, and R. Now we have to find them, we have to think them, right? So P plus T is equal to P1. So P, which is -1, -6, plus 4, -1, because that is translation vector. So -1 plus 4 is -3. No, +3, sorry. And -6, a plus and a minus, so -6 minus 3 is -7. So that was for P. Let's look at Q. So it's Q plus T is equal to Q1. If I said inverse, please forgive me for the one on top. So it's -5, 0, plus T, which is 4, -1, is equal to, so -5 plus 4, when the signs are different, you find the difference, which is 1, and keep the sign of the greater number. And of course, -1. And R plus T is equal to R1. So R, which is 0, 7, plus T, which is in this case, in this question, 4, -1. 0 plus 4 is 4, and 7, a plus or minus, a minus, so 7, take away 1 is 6. Oh dear Lord. You all have any questions there?
No, sir.
Okay, now suppose you want to see how this would look on a diagram, right? Let's say we had to a Cartesian plane. They give you the points, and you have to plot the image as well as the object, right? This is what it would look like. Let me just show you all. Right? Here we're seeing P, and then we have with a new value for P. This is where P1 will be. Here we are seeing Q, and our new value for Q. This is where Q will be. Here we are seeing R, and a new value for R will be here. Right? You all clear with that? As you all can see here, our value for R1, sorry, P1 was 3, -7. So as you all can see, 3 on the x-axis, -7 on here. So that's where P is. And our new value for Q, which is Q1, was -1, -1. As you all can see, it's right here. Right? And of course, R1 is 4, 6. So 4 on the x-axis, 6 on the y-axis, that's right here. Everybody good?
Yeah.
Okay, great. So that was it for translations. Let's look at reflections now. So we define reflection as a transformation in which the object turns about a line called a mirror line. In doing so, the object actually flips, leaving the plane and turning over so that it lands on the opposite side. In reflection, am I breaking up or you're hearing me properly?
We hear you fine.
Okay. In the reflection below, the triangle on the left, which is the orange one, is the object, and the triangle on the left is the image. So the object is the original thing, right? And the image is whatever is when the object undergoes translation or the transformation. So yeah, the mirror line is a vertical line. The image has a different orientation to the object and is said to be flipped or laterally inverted. So if we try to slide the object across the mirror line to fit on its image, it will not match. That's what laterally inverted means. So if we were to slide the blue triangle across to the orange triangle, it will not match up because it's laterally inverted or flipped. Yes, people? So describing a reflection, to describe a reflection, we state the position of the mirror line. That is, the straight line in which the object is to be reflected. Now, the mirror line can be any straight line, whether it's vertical, horizontal, slanted, or diagonal, etc., right? When we perform reflections on a Cartesian plane is this grid, this thing here we use when we do graphs, that's a Cartesian plane. When we perform reflections on a Cartesian plane, we usually describe the position of the mirror line by stating its equation. So let's look at variant and invariant points. So this is a variant. Let's look at invariant points first. If an object point is mapped onto itself after transformation, that point is said to be invariant. So in reflection, if an object has a point that lies on a mirror line, then the object of this point will be the same point and will coincide with the object point. As such, only points on the mirror line are invariant points under reflection. So what it is saying is if the object touches the mirror line and the image also touches the mirror line, then we have an invariant point, more or less, like this diagram here. The mirror line is this black diagram here, this black line here, and we have the object on the mirror line itself and the image also on the mirror line itself. So here, therefore, we have invariant points, more or less. Okay, let's look at some examples of lateral inversion. So we have the object B. If it's laterally inverted about the mirror line, we have the image B looking back for front. Same thing with L and L. A, however, this is, just a minute, I think I missed the point. Right, however, for letters such as A and M, as we can see here, although lateral inversion takes place, the images, they remain unchanged. So if you slide across the A here, it will still remain an A. If you slide across the M here, it will still remain an M. Now, because of this lateral inversion here, when we have the ambulance passing behind you, if they just write the word ambulance properly, if you look at it in your rearview mirror, you will not be able to understand what is written. So the words in the ambulance are laterally inverted in the front of the ambulance. I'm not sure if any of you ever noticed that the ambulance in front of it, the word ambulance is written back for front kind of in a way, as you always say. It's laterally inverted, so that way, if the ambulance is behind you, when you look at your rearview mirror, for those of you who actually drive, when you look at your rearview mirror, you will actually see the word written ambulance as opposed to a laterally inverted image.
Sandra and me did that in physics, so they should know that.
Yeah. So you all follow?
Yes, I do.
Okay, great. So let's see here. A line segment PQ with P, which is 1, 2, and Q, 3, 4 is reflected on the x-axis. Perform this reflection and state the coordinates of P1, Q1, which is the images of P and Q under the reflection. So let's see it here. So here we have P, which is 1, 2, 1 on the x-axis, 2 on the y-axis. That's P here. And then Q is 3, 4. So as you can see, 3, 4. And the question, did it tell us? Okay, now let's to perform a reflection on the x-axis. So as you can see, this is the x-axis here. We are using the x-axis as the mirror line. So in that case, we count how many blocks from the x-axis to P. So 1, 2. So if this is the x-axis here, And this is the mirror line. We count how many blocks again. 1, 2. So P1 is right here. And let's look at Q1 from 3. It's 1, 2, 3, 4. So from 3, it'll be 1, 2, 3, 4. So Q1 is right here. Any questions so far? You know, you can answer, right? Beside David, you can actually answer.
Yes, sir.
Okay. So let's look at this one here. Triangle A1, B1, C1 is a reflection of triangle ABC. State the mirror line here. Well, it's very clear that the mirror line is this white, sorry, is this red line here. Yeah? So its y is equal to 2. This line here is y is equal to 2 because y is 2. It's on the y-axis, so y is equal to 2. That's the position of the mirror line, right? As you can see here, y is equal to 2. When we come to do linear programming, you will understand that more in depth. So any questions so far?
No, sir.
Okay, great. So obviously you all can draw right now. So if you all did have to draw, let me just show you a little trick. Just memorize that question, right? So this here is more or less the diagram here, right? Diagram that we have here. So let me just show you a little trick that I teach my students. It's actually a shortcut way, and it works. For some strange reason, it works. So you will take your compass. You will need your compass for this, right? So this is the mirror line here. All I tell them to do is take their face and pen it here like this on the mirror line, right? As you can see, it's on the mirror line itself here, right? And of course, take your pencil or pen or whatever and darken the points here so that it prints out at the back of the paper, as you can see here. Right? You all see the 3 points printing out here. And then, of course, you're going to take your compass and stick a hole where you see the points. Right? 1, 2, 3. Make sure it goes through the paper, right? I can't press too hard because I'll damage my whiteboard. Oh my God, I think I already did. Oh Lord. Yes, I did. So, right, you punch in a hole here. But just try not to punch no hole in the exam because the people are going to do this method and they know you didn't work it out properly. Right? And of course, when you open your paper, you will actually see where the points are supposed to be. So it's here, here, and here. Okay? Everybody follow? You all note that little cheating method there? You think you all remember it? It's a little work, but trust me, it will save your life in the exam. And I know this because when I was a student, I could never do that. And I was sitting down in the exam thinking, oh my God, I'm going to fail this, I'm going to fail this, I don't know what to do. So that time I say, if this is a mirror line, if I fold a page like this, and I take my compass and I stick it, it must reflect and show my hair because I didn't want to work it out and I didn't know what to do. So that's why I did it. And I started to teach my students that after. Of course, if you have to show your working for it, then that's a different story altogether.
And say it help.
Huh?
And say it help.
Well, yeah, I got one. So yeah.
So if I didn't know what to do, I would try and look at somebody else's paper.
But still, I wouldn't really help you to give you a more accurate thing of the point. So, by the way, as you all can see here, I get, oh God, mine a little off. It's off, yeah, it's off. A little thing because of my, because remember, I enjoy the scale. So obviously you will be using graph paper. So yours will be drawn to scale, right? And your values will be more correct than this. Okay? So let me just show you what the diagram is supposed to look like. Right? Look at it. Yep, people. So let's look at this diagram here now. Reflect ST. Let me do this on paint folio. Right. We are asked to reflect the line y is equal to -3. So we have to locate -3, that's right here. So let's draw a line, the mirror line. Everybody's seeing it there, right? Between -4 and -2 is -3. So if we were to reflect this point now, where's that different? Let me use the red. So this is where T is. As you all can see, it's one block away from the. Let me zoom in a little bit. So it's one block away from the mirror line. So that means that T is right here. T1, that is. And S is 2 blocks away. So 2 blocks away is right here. So that means that S1 is right there. So let's draw our new line. And that's it. Any questions?
No, sir.
Yeah, easy, right?
Yeah.
Okay. Let me just show you all the actual answer. Which is basically the same thing I got, right? And they ask you to state the coordinates. Obviously, you know the x coordinates goes first. So the x coordinate here is 7 and -2. That's for T. And for S, x is -2 and y is -1. So that's how I got these coordinates here. Anybody confused or anything so far?
No, sir.
Okay, great. So I will not be going through lines of symmetry because I mean you all know lines of symmetry long time from since primary school. I will also not be doing rotations because obviously the exam is going to be a multiple choice exam. So I'm going to be looking at enlargement. Okay. So I will send you all the handout on enlargement, but I want to try some multiple choice papers with you all here and see if based on the multiple choice, you all will be able to more or less figure out the answer. Yeah. So let's do some multiple choice. I'm giving you all a 5-minute break just for me to organize my multiple choice papers for you all. Is that okay with everybody?
Yes, sir.
I'm just going to pause the recording, right? So somebody just remind me to unpause it. Right, so try these questions for me. Thank you, David. All right, 3 questions from June 2014. And I'll be calling on some people to answer this for me, right? So I only have about 5 minutes to do that. On this side, I'm going to put Jan 2014. You getting through? If you are finished, feel free to share your answers.
So I get A for the first one.
Okay. It's probably correct or probably wrong. 1 out of the 2. Which one do you think it is? Is it correct or wrong?
Incorrect.
All right, now we go see. Jan 2015.
But the first one is D.
Probably. June 2015 as well. Let me see. Oh, I don't have that. Oh, yes, I do. Okay, can we correct?
Yeah.
All right. So let's now let me just pack it up my past papers. Right. So yeah, so June 2014, number 56. What you all said it was?
D.
D, yes. Let's see. Negative, just now let me get to that brush. Negative 2, 3, plus our translation, 3, 4. Negative 2 by 3 will give us positive 1, and 3 by 4 is 7. So the answer here, yes, it is D. Let's look at the other question. So the graph above, in the graph above, the line CD is the image of AB after, is it what? A rotation of 90 degrees, a reflection on the y-axis, C, a translation vector -4.8, or an enlargement factor. What do you all think it is? Johnson, what do you think it is?
A reflection.
Correct, it's a reflection because the y-axis here, it becomes a reflection for this line as well as this line. So yeah, B. Number 59, the line segment AB is rotated through 90 degrees clockwise about the point C. The coordinates A1, the image of A, are what? Anybody? So if it's rotated through 90 degrees clockwise, what do we do? People, we just did this, sir. Anybody have an answer for me?
No, sir.
Huh? So what is the coordinates for A? A, just have somebody say the answer. One moment. Yeah, yeah, David, I could work it out. You want me to work it out?
Yes, sir.
Okay, so the coordinates for A would be what? Just now, hold on. A is 2, 3, and undergoes. One moment. I think I'm overthinking the question. The line segment AB is rotated through 90 degrees clockwise. So if it rotates 90 degrees clockwise, that means it's coming down this way. The coordinates of A1, the image of A, it has to be B. There's 1, 2. If it rotates 90 degrees clockwise. So it's negative. Yeah, it's B. Anybody wants to explain why I got B and how I got B? Johnson, how you got B?
Well, I don't know how, well, you kind of like have to like mentally rotate it 90 degrees.
Yeah, that's what I'm trying to figure out how to explain it for you all. But yeah, go ahead and explain it. How you mentally do it. Maybe you might be able to explain it better than me.
Well, I don't know how to put this, but like, so if it rotates in about the point C, it have like a space like one block from A. So when you rotate it 90 degrees, it's you're supposed to get like A kind of like down from C, like one block down from C, and then you just take those coordinates for A.
Which is right here, right? Yeah?
Yeah.
So yeah, that's how I got it as well. I just okay, so it's above, it rotating above C. So the coordinates will end up being right here. There is no working really for this. It's a mental thing. You have to do it. I hope you're okay, David.
Well, so a 90 degrees line would be perpendicular to the that's C. So if you connect the line from C to 1 and you mentally C, you just where 1 and 3 is, that's where C is, right? And you just rotate the line to 90 degrees, it will give you the perpendicular. Remember, if it's 90 degrees, the line's supposed to connect as a perpendicular. So you connect the line from C down, you're just drawing the line down and you'll see where A will end up.
Yeah.
That's as simple as that you can do it, unless you have a protractor and you want to do all that.
Exactly. Yeah. If I have to do this, I would use a protractor. But obviously, I don't think you're allowed with protractor.
But kids should know that a 90 degrees angle is formed when two lines are perpendicular. So you just draw the perpendicular line and connect it, and you'll see where it will happen. The reflection is.
Correct. Okay, so let's look at Jan 2014. The image of point P, which is -2 and 3, undergoes a translation 3, 4. So let's see here. -2, 3.
Same question.
Right. Yeah.
Because the answers are now, it's not in the same order, A, B, C, D,
yeah. So the answer is C here. So let's look at this one here. The transformation, which will map triangle PQR onto P1, Q1, R1 is a rotation of 180 about the origin, a reflection on the line y is equal to x, an enlargement, definitely not. Translation parallel to the x-axis, which one do you think it is? If it moves from here to here, that's 90 degrees, and then from here to here is the next 90 degrees. So how much degrees is that? And 180? So the answer is A. Let's look at the other one. In the diagram, the triangle ABC is mapped onto triangle A1B1C1, where O is the center of enlargement. What is the scale factor of the enlargement? So as you all can see, C, which was 2, it went to 4. A, which was also 2, it went to 4. And B, which was 3, it went to 6. So what do you all think the scale factor there is? What, when multiplied by these, gives us those?
2.
Correct. So D is the answer. Yeah? Any questions?
No.
All right. So let's try our next set of particles. The That was 2014 we did, right?
Yes.
Okay, so this one is from June 2016. As soon as it comes on the screen, try doing, you will start doing it, right? All right, it's on the screen. One of the question. And you all see actually how many questions are repeated and stuff, right? All right, try those questions for me. And be correct in 10 minutes.
For question 55, what diagram are we looking at?
Question 55.
John 2015.
Oh, just a minute.
Okay.
$55. Oh. Right. Are we correct now?
Yes, sir, go ahead.
Okay, June 2016. Number 52. Anybody wants to give it a try?
D.
D, yes. So it is a reflection. It does a very easy one. The image of point P, which is 1, 2 under transition is -4, sorry, -5, -4. What is the transition vector? Anybody?
B, sir.
B, no.
A.
Yes, E. I'll tell you why, David. Because it's 1, 2, that's P, right? And if we add, let's try 6, 6, -6, -6. 1 plus -6. A plus by minus is a minus. So 1 take away -6 is -5. And 2 take away 6 is 4. -4, of course. So that was the only one giving us that there. -6, -6. Okay? Yeah, Bridge Mohan, I think was you who asked the question. So let's look at number 59. What is the scale factor of enlargement? So we went from 1 block to 2 blocks, from C to B, and then from C to A, we went from 2 blocks to 4 blocks. So can you all determine what is the scalar factor there?
2.
Huh?
2.
Yeah. Which is what?
C.
Yeah, just now what? Well, we can't tell for sure if it's positive or negative, so I don't know why I have -2 there. So number 59. Hold up. Straight line C, ABC is mapped onto ABC by a scale. Oh, what is the scale? OAA. I'm not reading the question properly. OAA and OBB and OCC are straight lines. Triangle ABC is mapped onto triangle A1, B1, C1 by an enlargement with center O. What is the scale factor of the enlargement? So yeah, C. Let's take a challenge 2015. Anybody have any questions? I mean, any answers for me there? Under the translation,
D.
it's now I don't work it off. So 3, 5, add 2, -3. 3 and 2 is 5, and 5 minus 3 is 2.
5, sir.
So that would be 8 here. -8. So yeah, D. Let's look at this next one here. What is the answer?
B.
B, let me see. In the diagram, the translation by which AB is mapped onto A1, B1 represented by. Okay, so let's look at A1. In this case, it's A1 minus A, right? So it's 4, 6, take away 2. Oh, wait, hold on. 2, just now, 5. 4 take away 2 is 2. 6 take away 5 is 1. Where you say B? You say B or A?
I said B.
Okay, let me just double check that. In the diagram, the transition by which AB, so A, right? Let me just try back. Let me try with B now. B1, take away B. So it's 7, 8, take away 5, 7, 5, 7. 7 take away 5 is 2, 8 take away 7 is 1. So yes, it has to be B. So yes, B is the answer. Let's look at this next one, June 2015. What is the answer?
D.
Where is it? D?
D for dog. B.
Okay. And the diagram is mapped on to, okay, what type of transition is this? One minute. Yes, it is a rotation. So yeah, rotation. And of course, number 58 is a repeated question, so we know the answer here automatically is B. So that's it. You don't have any questions for me?
No, sir.
All right, well, we have successfully come to the end of this class. So let me just stop the recording so Lyndon can get it.